This is Chapter 2, Problem 20. Chapter 2, Problem 20 gives us the equation of x equals 16t times e to the minus t, and asks us to find how far the particle is from the origin when it momentarily stops. Momentarily stops means velocity equals 0, so that should say to you, take the derivative of this equation, set it equals 0, solve for t. In order to take the derivative, you have to realize that this equation is really two equations times one another. The first equation is 16t. The second equation is e to the minus t. Since it's two equations times one another, you have to use the product rule. Remember, the product rule is the first equation unchanged times the derivative of the second equation, then the second equation unchanged times the derivative of the first equation, and those two things added together. So our second equation is e to the minus t. But really, it's not h of x, it's h of t, so I'm going to change it to h of t. To understand how to take the derivative of e to the minus t, you have to understand that e to the minus t is really minus 1 times t. So h of t equals e to the minus t is really the chain rule. So to apply the chain rule, I take the derivative of e to the minus 1 times t, and the derivative of e to the t would just be e to the t. So I'm going to write the derivative of e to the minus 1 times t equals e to the minus 1 times t. But then I have to finish the chain rule. I have to multiply by the derivative of this equation that's the equation inside of the equation, and the derivative of minus 1 times t is minus 1. So finally I have the derivative of e to the minus t is in fact minus e to the minus t. Now back to our original equation. I now know that this derivative here is minus e to the minus t, and then I have my first equation, which is just 16t, and that's going to be unchanged. So I'll have 16t times minus e to the minus t, and then I have to finish my product rule. The last part of product rule is the second equation unchanged times the derivative of the first equation. The derivative of 16t is just 16. So notice the effect of product rule is usually to take two equations times each other as just one thing, and make it into two equations times each other, and then add it together. So product rule generally expands a single equation. In order to simplify this a little bit, I'm going to factor out 16 e to the minus t, because I'm ultimately going to set this x prime of t equals 0, because remember my original plan is to set velocity equal to 0, and the only way I can do this is to factor. So I'm going to set x prime of t equal to velocity, and then I'm going to set velocity equal to 0 because the problem originally asked, when does the particle momentarily stop? When you have two equations multiplied by each other, set equal to 0, as I have now, what you do is you set each equation equal to 0 separately. So 16 e to the minus t equals 0 says that at t equals infinity, it's going to stop. So velocity is 0 when t equals infinity. But the more interesting answer is the 1 minus t equals 0. 1 minus t equals 0 is at t equals 1 second, this part is also 0. So I have two times where velocity is 0. One is at t equals infinity, and one is at t equals 1 second. To find out the answer, I have to take t equals 1 second and plug it back into my original equation for position, because remember the problem originally asked me not when does the particle momentarily stop, but how far from the origin, that's x of t, is the particle when it momentarily stops. So I just plug in 1 everywhere I see a t. So the answer is 16 divided by e, and you may know previously e is 2.71. 1828, 1828, 45, 90, 45.